टिकी तू मिल जाए अभी, तू मिल जाए अभी। मैं माना तेरी हो ना सकी पर
in an array of distinct elements, which is initially sorted in ascending order, but then rotated at some unknown pivot. And the task is to find the index of the target key, which is given here as input. And if the key is not present in the array, then we need to just return -1. So here given constraints are 10 raised to 6 and also the values are from 10 raised to 0 to 10 raised to 6. So looking at this question, the first thing you could think of is a normal linear reversal because it satisfies our constraint as well as it is a normal way to search the array. So writing its code here as it is like really simple. I have written the code. Let me first so as it is really simple, we have just written the code. We have first taken the size of an array, then run the for loop from 0 to n. And if the array I matches the key, then I will return I, else I will return -1. Yeah, this is just a normal approach. And now, since we are given, as you observe that in the question, we are given that the array was initially sorted in ascending order, but as it is said that it is rotated at unknown period. And as I heard that array is sorted, I could think of a binary search approach in this. And for the binary search approach, as it is rotated on some index, I think that just let me sign in first. Okay. Till then, let's discuss our approach. So this would be array, and suppose we would just take the mid as I plus j divide 2, and after it, here in this array, mm, the first given example, uh, here it reaches this index, and after it, as you can see, one part could be considered not sorted, and while the other part could be considered as sorted. Then we would compare the mid element with the left index and the right index. So the in a normal traditional sorted array, the right index should be greater than the mid element, and the left index should be smaller than the mid element. So if then we would check if this satisfies that the left index is smaller than the mid index, then we could come to a conclusion that this part is sorted, and then we would just go into this part, and then we would check if our key which is here 3 satisfies this range of 5 to 9. Does the key lie in range 5 to 9? If so, then we would go into this array and search it. Else, we would go into this array and search it. So, after coming onto this array, we would again repeat the same thing. We would search in the sorted array, uh, like search in the sorted array if it uh, satisfies the range, then we would search in the range, and then it will be just a normal binary search. else we would just go to the unsorted part. Okay. I don't know what happened now. No, I just should have taken. Okay. Doing this now. Let me just go with this. So I think we have understood the approach. Now let us go on to the implementation. First we need a pointer I, then a pointer j, which is 1 is to 9, 1 is to 6 as per our constraint, and we will check this binary loop until I less than j. For y, if you ask y of y I less than j, then you could say that the mid could be equal to I as well as j, or it could, if there is just I less than j and I not less than j equal to less than equal to j, then it would left one element which might be our key element and it is crucial, so we will go to the uh, from end to end of I less than equal to j. Then we would find the mid as I plus j divide 2 uh, divide 2 if array of mid is equal to key is equal to our right just key, then we would return mid, else if array of mid greater than array of L greater than or equal to I here, I suppose, because for an array of just one element it will be greater than equal to, so array of one element is just sorted basically. So if this is so, then we could consider that this element, this row is sorted. Then we would check if array of mid greater than equal to key and array of and our element at the left index is less than equal to key. If so, then we would do L equal to, we would do R equal to mid minus 1. Here minus 1 because we are checking that array of mid is not equal to key, so it is just no point taking it as mid. Else we will do L equal to mid plus 1. Similarly, for this, we will also do the same as if the right part is sorted, then we will do mid greater than equal to array of, so, sorry, mid less than equal to array of the less than equal to the right pointer. Then we will do L equal to mid plus 1, else we will do R equal to mid minus 1. Uh, mid less than equal to R. Okay, let's just check again from the top. Here are defined as size n. Then we are given our. I don't think this just need to be n minus 1 here because we are not doing search on index. We are doing search inside the array space, so it will be n minus 1. Then we are doing binary search with mid of I plus j by 2. Then we are checking if our key is equal to mid. If so, then we are returning mid. else we are going else we are checking if the left part is sorted. If so, then we are checking if our mid lies between our if our key lies between the range of mid to L, then we are just doing then the sorted part contains the key, and we are just taking the right pointer and putting it into a mid, pointing it to a mid minus 1. Else we are doing L equal to mid plus 1. So this I think it's okay. Then to this I think it's okay. And coming on to this part, we are checking if this part is not sorted, then we could assume that the right part is sorted. Yeah, this could be example here. When the right part is sorted, then we will check if our this condition here is wrong. Then we check if our element lies between greater than equal to less than equal to p and greater than area of r greater than equal to p. If so, then we would just increment, like increase our left pointer to mid plus 1, and else we would increase our right pointer to mid minus 1. And if we don't find it, then we would just put in minus 1. Sorry, I have written L and R here instead of I and J. Instead of changing in this, I would just change it over here. There's still some error, numerical R and O. Okay, this should work. Yeah, it is working. And on submission, yeah, it passed all the test cases. So this is the solution. Thank you for watching. It was great.